Digital subscriber line, DSL, originating as a digital subscriber loop, encompasses a range of technologies utilized for transmitting digital data over telephone lines. Within the realm of telecommunications marketing, DSL commonly refers to asymmetric digital subscriber line, ADSL, the prevailing DSL technology deployed for internet connectivity. ADSL distinguishes itself by offering higher data throughput downstream toward the user compared to upstream, symbolizing an asymmetric service. Conversely, symmetric digital subscriber line, SDSL services, provide equivalent data rates for both directions. DSL service can coexist alongside wired telephone service on the same line due to the usage of higher frequency bands for data transmission. To prevent interference between DSL and telephone service, a DSL filter is fitted on each telephone on the customer's premises. Consumer-grade ADSL services typically exhibit bit rates ranging from 256 kbit SES to 25 Mbit SES, whereas the more recent VDSL Plus technology offers speeds from 16 Mbit SES to 250 Mbit SES downstream and up to 40 Mbit SES upstream. The exact performance is contingent on the technology, line conditions, and service level deployment. Researchers at Bell Labs have successfully achieved SDSL speeds exceeding 1 Gbps using conventional copper telephone lines, albeit such speeds have not yet been commercially accessible to end users. Initially, there was skepticism around the capacity of ordinary phone lines to support high speeds, with typical rates believed to be less than 9,600 bits per second. Nevertheless, experiments in the 1950s showed that ordinary twisted pair telephone cables could transmit 4 MHz television signals, hinting at the potential for transmitting data at much higher speeds. However, various impediments aside from Gaussian noise hindered practical realization in the field. The breakthrough for broadband communications emerged in the 1980s through the development of techniques extending the transmission limits. Notably, a patent in 1979 proposed leveraging existing telephone wires for telephony and data transfer to a remote computer using a digital data carrier system. The inception of DSL technology was motivated by the Integrated Services Digital Network, ISDN specification from 1984, leading to the introduction of asymmetric digital subscriber line, ADSL, by Bellcore employees. Subsequently, in 1988, AT&T Bell Labs filed a patent outlining the fundamental DSL concept. A significant contribution to DSL advancement came from Joseph W. Lechleiter, who advocated for an asymmetric approach to enhance bandwidth capacity, enabling Internet service providers to offer efficient data services to consumers. The evolution of ADSL to support fast and interleaved channel modes catered to varying needs like multimedia streaming and file transfers, respectively. The deployment of DSL entails intricate digital signal processing algorithms to address the limitations of existing twisted pair wires. By the late 1990s, the cost of DSL equipment decreased substantially, primarily due to advancements in very large-scale integration, VLSI technology. A critical component of DSL infrastructure includes a digital subscriber line access multiplexer, DSLAM, and a DSL modem, allowing for cost-effective setup compared to laying new fiber optic cables. The proliferation of DSL technology signifies an amalgamation of enhanced performance and reduced costs, rendering ADSL a more favorable choice for Internet access over traditional dial-up services. The competition posed by cable companies utilizing DOCSIS technology further prompted telephone companies to adopt ADSL technology to cater to the escalating demand for high-bandwidth applications. The advent of DSL not only revolutionized Internet access for consumers, but also facilitated the convergence of voice and data services over a single line, marking a significant milestone in telecommunications evolution. At the customer's premises, a DSL modem is connected to a phone line, which then links to a DSLAM, digital subscriber line access multiplexer, on the telephone company's end. The DSLAM consolidates numerous individual DSL connections into one unit. To prevent signal loss, the DSLAM must be located relatively close to the customer due to attenuation issues between the DSLAM and the customer's DSL modem. Typically, several residential blocks are linked to a single DSLAM for efficiency. The customer setup may include a DSL modem with an optional router, managing a local network connecting various devices. Some modems integrate routing and wireless access, streamlining the connection process. At the telephone exchange, the DSLAM terminates the DSL circuits, aggregates them, and transfers them to other networking systems like a PON network or Ethernet. It extracts the original digital data while separating the voice component in the case of ADSL. Load coils in phone lines, mainly used in rural areas to extend coverage, need removal to enable DSL operation, as they only allow low frequencies up to 4,000 Hz through phone cables. Customer equipment consists of a DSL modem that converts data between digital computer signals and analog voltage signals within a suitable frequency range applied to the phone line. Depending on the DSL type, the modem can directly link to the computer or integrate higher-level functions like routing and firewall capabilities, known as a gateway. Installing DSL filters at the customer's premises to distinguish DSL from voice signals is common, either at the demarcation point or within telephone outlets. Some DSL gateways integrate filters to allow telephones to connect through them. Upon booting, the system synchronizes the DSL connection, establishing internet services through protocols like DHCP or PPPoE to connect the local network with the service provider. Various DSL technologies employ different transmission modulation methods such as DMT, TCPAM, and CAP. Implementing protocols like ATM over a bitstream layer allows the adaptation of multiple technologies over one link. DSL configurations can be bridged or routed, creating either a unified or individualized subscriber network. Authentication for the IP address varies from DHCP using MAC addresses to PPP with user ID and password. DSL standards include a range of technologies like SDSL, IDSL, HDSL, VDSL, and ADSL with varying symmetric and asymmetric bit rates, catering to different needs. For instance, VDSL is known for high-speed short-range links, often used in delivering triple play services. Terabit DSL proposes utilizing space between insulators on copper-twisted pair lines as waveguides for ultra-high-speed signals, potentially offering speeds up to 1 terabit per second at short distances.